This is a quick tutorial video demonstrating how to determine the molecular weight of a compound given that you have its formula. This does operate under the assumption that you are able to read the name and, using the rules of nomenclature, your knowledge of common ions as well as polyatomic ions, deduce what the correct chemical formula is. So starting with a formula, it's straightforward to write out how much we're going to get in contribution to the molecular weight from each of the elements. So for potassium hydroxide, we can look to a periodic chart and to one decimal place determine that we'll have 39.1 grams per mole from the potassium, 16.0 grams per mole from the oxygen, and 1.0 grams per mole from the hydrogen. And this will give us a total of 56.1 grams in 1 mole of potassium hydroxide. This one is very straightforward because you only have one copy of each element in the formula. For aluminum oxide, we do have to pay a little more attention. Al2O3. So each aluminum will give us 27.0 grams per mole, and we have 2 of those. Each oxygen will give us 16.0 grams per mole, and we have 3 of those. If we multiply through and then add everything, we'll find that we have 102.0 grams in 1 mole of aluminum oxide. We do a similar thing if we have a subscript multiplying a polyatomic ion. In this case, calcium cyanide. From the calcium, we get 40.1 grams per mole. That carbon is going to give us 12.0, and the nitrogen will give us 14.0. And in this case, we want to multiply the entire polyatomic ion by the subscript on it. And if we multiply through and add up, we get 92.1 grams and 1 mole of calcium cyanide. Iron 2 phosphate, we follow all of the same rules as before. It may look more involved and possibly a little bit more intimidating, but realistically we already know all of the rules here. So we go to the periodic chart, we find that iron is going to give us 55.8 grams per mole. For phosphorus we have 31.0, and for oxygen we have 16.0. And we know that these guys are going to be multiplied here because we have 4 oxygens and we have 3 irons. And here we multiply the entire polyatomic ion by the subscript associated with it. And in this case we end up with a value of 357.4 grams in 1 mole. So the final one, mercury 1 perchlorate. Mercury 1 is a polyatomic ion itself. And from the periodic chart we have 200.6 for each individual mercury. For chlorine, 35.5, and oxygen, again, 16.0. And we know that we're multiplying the polyatomic by 2, and we have the subscripts that came with everything. We have a 2 here and a 4 here. And multiplying through will give us a value of 600.2 grams in 1 mole of the substance. So using this basic procedure, it's possible to actually determine the values of the molecular weight of any compound once you're able to translate it from words to a chemical formula.